My name is Jayant. Welcome to Maths with Jayant. Today we are going to learn about prime factorization. In our previous video we had discussed about prime and composite numbers. So today it's a bit continuation of the topic and we are going to learn about prime factorization. That means we are going to find the prime factors of a particular number. So if there's a composite number like 4, 6, 8, 9, okay. So if we will see, then we'll see that each of these numbers, we multiply prime numbers only a certain number of times and we are going to get the number. Like 4 is 2 into 2, 6 is 2 into 3, 8 is 2 into 2 into 2, 9 is 3 into 3, and if we take 10 then 2 into 5. So we multiply only prime numbers a certain number of times to get a composite number. So composite numbers are made by multiplying prime numbers a certain number of times. So this is the number and these are the prime factors of the number. So this is the prime factorization. So today we are going to learn two methods of finding this. So let us get started with today's topic. So let us start with the first method. So the first method is called the factor tree method. It is called the factor tree method. So let's see. So suppose you need to find the prime factors of the number 4. So what are you going to do? So you need to think of any two numbers that you multiply to get 4. This is our first step. Think of any two numbers that we can multiply to get 4. So you might be saying 1 into 4 gives us 4. But this does not help us. 1 is, we cannot write this 1 over here. So 1 is not allowed. So think of some other numbers. I think 2 into 2 gives me 4. We all know this. So now we have written this. Now check for the prime numbers over here. So are any of the numbers prime? Yes. We know that 2 is prime. So when all the numbers are prime and you can't prime factor the prime numbers anymore, this means that the prime factors are done. The prime factorization is over. So this shows that 4 is 2 into 2. This is the prime factorization for 4. So now if you are confused, then don't worry. We will solve more examples. Let's find the prime factors of the number 12. So let's think of any two numbers that we can multiply to get 12. So 3 into 4 gives us 12. So these two numbers we can multiply to get 12. So find for the prime numbers, and the prime numbers have to be circled. So 3 is a prime number and 3 is circled. Is 4 a prime number? 4 is not a prime number, it is a composite number. So we can't circle this. So what should we do with the composite number then? Now we need to think of two numbers that will give the composite number. So 4 has to be broken down more. So now if I think what two numbers should give me 4. So I think 2 into 2 gives us 4 and that's obvious. So this means that, and now let's see the numbers that are prime. Both 2's are prime, so I've circled them. And now we can't factorize any of them more further. So this means 12 is going to be 3 into 2 into 2. Right? Now you might be saying, when you tell me 12, I think that 2 into 6 gives me 12. So 2 into 6 gives us 12. This is also correct. So now look for the prime numbers. The prime number is 2, but 6 is not a prime number. So we are going to factor 6 again. So 6 is 2 into 3. 2 into 3 gives us 6. And both 2 and 3 are prime. So over here we can stop and 12 becomes over here becomes 2 into into 2 into 3. So this shows that no matter how we do the prime factorization, if the numbers, the steps are correct, then the prime factorization will be correct. So in both ways you can see that it's same. 3 into 2 into 2, 2 into 2 into 3. Both are the same. So this is one thing for prime factorization that you need to know. Now let us factorize a 3-digit number. So let's take which number? Okay, let's take 240. So let's think of any two numbers that we can multiply to get 240. So now if you know the divisibility rules, you can apply them over here. So 240, it is an even number, so it is divisible by 2. So we can write 2, and 2 into 120 gives us 240. So 2 is a prime number, but 120 is not. 120 is again an even number, so we can divide it perfectly by 2. It is divisible by 2. So I will get that 60 into 2 gives me 120. 2 is a prime number, but 60 is not. 60 is again one number divisible by 2. So it is divisible by 2. And 60 is 2 into 30. So 2 we'll circle. Now 30 is again divisible by 2. 2 into 15 gives us 30. And 15 is a composite number. It has to be again factorized to 3 and 5. And 3 and 5 are prime. So now we can stop, and then we get 240 as 2 into 2 into 2 into 2 into 3 into 5. And if you want to check if this is correct, so you can multiply and check. 2 into 2, 4 into 2, 8 into 2, 16 into 3, 48, and 48 into 5. If I multiply and check, I'll get 240, which is just exactly the same. So the prime factorization is correct. But we always cannot apply this method because there are a few issues in this method. One is that sometimes if the numbers are fully repeating, like over here we had 4 2s, 2 into 2 into 2 into 2. So first thing, it can become really confusing by missing out for a number. Second thing, it occupies lots of space. Yes, it does occupy a lot of space. Like if this is a number, then this, then this, then this, then this, then this. And even these numbers have to be factorized sometimes further. So this method occupies lots of space also. So let us learn the second method. This method does not have a name, but this is also a nice method. So over here, let us start with 12. So 12, what you have to do is that you need to make an L sort of a thing around 12. It should look like this. If this is a number, it has to be like this. So we made an L sort of a shape around 12. So now this is like division. So what you have to do is that think of any prime number that we can perfectly divide by 12. So it is divisible by 2, we know, and 2 is a prime number. So we can write 2 over here, and 12 divided by 2 we should do, and we will get 6. Now this has to, again we have to make an L around it. So we need to make L's like this till we get a 1. So now 6. Think of a prime number that we can it is perfectly divisible by a prime number. So I think it's again an even number, so it is divisible by 2. 6 divided by 2 is 3. So we have not reached 1 yet. So 3, again we have to make an L around it. Now 3 is a prime number. It's only divisible by 1 and itself. So we'll write 3 over here. 3 divided by 3 is 1. Now we've come with this 1, so we have to stop at this point. We are now going to make an L for the 1. So what is the prime factors for this number? 12 becomes, all these numbers we need to write like this, 2 into 2 into 3. So now let me just give you a small important tip for prime factorization. We always write it in this format by putting into signs. We never write word commas. This method is not allowed. We should use this method. Okay, so now moving on. Let us solve another example for 2 digits so that this method is clear. Let's take the number 70. So let's find the prime factors for the number 70. So it is an even number, so it is divisible by 2. So 70 divided by 2. 70 divided by 2 is 35. So 35 again make an L. It ends with the 5, so it is divisible by 5. So 35 divided by 5 gives us 7. Make the L around a 7. Now 7 is a prime number. It is only divisible by 1 and 7. And over here only prime number should come. 1 is not prime, so we should write 7. And then 7 divided by 7 is 1. So the 1 has come. So at this point we have to stop. So 70 becomes 2 into 5 into 7. Now let us find the 3-digit numbers prime factorization using this method. So now let us find the prime factors for 580. I've written 580 and made the L. So 580 is an even number, so it is divisible by 2. And if I divide and check, I will get 290. 290 is again even, it is divisible by 2. So the answer we will get is 145. This number ends with the 5, so it is divisible by 5. So we will get 9. So 9 into 5 should give us 145. Now 29, let's see. 29 is a prime number. It is only divisible by 29 and 1. So write 29 over here and 1 comes down. So over here 580 becomes 29 into 5 into 2 into 2. So hope you understood prime factorization really properly. So now if there are small numbers, you can use the factor tree method for small numbers. But if they are big numbers, then I would suggest you to use the L method. So these are 2 methods that we discussed in today's video. Hope you understood. Thank you.